Hi everyone, today I'm going to do a video about isotopes. So I'm carrying on with the GCSE chemistry series, and hopefully by the end of the video you are more aware or understand the term isotope. So I'll spell it out for you. Isotope. Okay? And there's only really a couple of questions they'll ask on this, and generally they tend to be in a higher paper, but it is in the specification that you need to know isotopes for foundation and higher. So an isotope is when you have the same element. So let's say you're looking at two different atoms that are the same element, for instance chlorine, but inside both the chlorines have a different atomic mass. So an atomic mass is how much does that atom weigh? What's the mass of that atom? And scientists, they discovered that the same element can be found. So let's say they look at an element and in it, it's got one proton. If it's got one proton in it, it has to be hydrogen because that number never ever changes. However, they found that some hydrogens weigh more than others. Now, if the number of protons never changes and the electrons, if you remember from another video, have a mass of basically zero, the only other thing that could affect the mass of an atom are the number of neutrons. So when scientists find atoms of the same element but they weigh different, it's because they are different isotopes of the same atom. So I'm going to give you an example now. Oh, sorry, pregnancy. Now this periodic table is a GCSE one. It's a little bit more simple compared to A-level ones. So a lot of the numbers, they're like whole numbers on here, except for this chlorine. Now in the box for chlorine, oh gosh, probably need a little table or something. In chlorine, you got Cl, and then the top number is 35.5, and the bottom number is 17. Yes, 17. So if you were to look on your GCSE periodic table, let's get rid of that. That is what, obviously a lot neater, but that is what the chlorine box will look like. Now in another video that we've already done or gone over, I told you the bottom number tells you how many protons are in an element, and that number never changes. So chlorine has 17 protons. Because elements are neutral and protons are positive, we know that if it has 17 positive protons, it will also have 17 negative electrons, right? We've also gone over the fact that every proton has a mass of 1. It's called a relative mass, and every neutron has a mass of 1, but electrons don't really have a mass. We say basically 0. This top number is telling us the atomic mass, and if you look, maybe I should stop putting this down. If you look at the key on that periodic table, hopefully you can see it, the top number is saying is the relative atomic mass. So that is telling us how much the atom weighs. And that mass, that weight, only can come from the protons and neutrons, because they're the only things in the atom that weigh anything really in relation to each other. So protons and electrons from the bottom number. Top number, do you remember I said to find out the neutrons, it's top number take away bottom? And that's because we know that 17 of the mass have come from the protons. It can't come from the electrons, so whatever's left over must be neutrons. Now 35.5, I should have a calculator. Take away 17 is what? 27. So if it was 37, it would be 20. So I'm taking it as 18.5. If my maths is right, 35.5 take away 17 is 18.5. That should mean really that chlorine has 18.5 neutrons. Now you can't get half a neutron, that's not possible. But what it is, the GCSE standards, they've put this one in to show you or give you an example of isotopes. And what it's actually showing is an average. So in actual fact, when scientists find chlorine in the atmosphere or in the universe, a lot of the time they find it with a mass of 35. I think it's called chlorine 35. But sometimes, about 25% of the time, they find chlorine and it's actually got a mass of 37. And the only thing that could be different in those two things are the neutrons, because if it had different number of protons, it would not be chlorine anymore. Don't know where my rubber is. So I'm going to show you a type of question they might ask. So I've seen this on a higher paper in this spec. It said, explain or describe the similarities and the differences between chlorine 35 and chlorine 37. It wasn't this exact element, but it was this sort of question. I'm just using chlorine, and the bottom number for chlorine is always the same, 17. So it was a 3-mark question, or a 2-mark, I can't remember, but they're quite common, and I've seen them across all specs. So the first mark would come from saying both chlorine 35 and chlorine 37, they both have 17 protons, because that number never changes. So if you said they both have 17 protons, you get 1 mark. If it's worth 3 marks, it'll be because the other mark comes from saying both of them, both isotopes of chlorine, both have 17 electrons. Okay? Because they're equal. Because we're not looking at ions now. There's no positive and negatives here. We're just looking at isotopes. The extra marks then come from, it might even be that this bit here is only worth 1 mark, because the last bit is most important. Now, chlorine 35, Cl, I've left myself no room. Chlorine 35 has how many neutrons? Top number take away bottom. So 35 take away 17 to me is 18. So chlorine 35 has 18 neutrons. Get rid of that magnet, don't even know what that's for. And chlorine 37, top number take away bottom number, has 20 neutrons. Sorry, my maths. I'm going to bring a calculator next time. I'm not a mathematician. So chlorine, looks like an I sometimes, but chlorine 37 has 20 neutrons. Now, if you can remember this, they're quite nice questions, but what I have noticed is I can be there in class, give an example of the question with one set of isotopes, and then get people to do their own, and they do struggle. So I think isotopes is sort of like, if you want your A star, you need to be familiar with isotopes. If you're looking for, to get a C, don't worry so much if you can't get your head around isotopes. So isotopes are when you've got the same element, but they have a different number of neutrons. Definitely going to get something to put my stuff on for future videos, getting bigger by the hour. Have had to take away though, so that might be why. Another example, sometimes in life, you get 3 different isotopes of the same element. So for instance, you could get, like on the periodic table, this is how carbon looks, carbon 12. So that's how it would look on our GCSE periodic table. But sometimes scientists find carbon 13. And sometimes they even find carbon 14. But in general, the majority are carbon 12. And here, what have they all got in common? They all have 3 not 3. There's 3 of them, sorry. They all have 6 protons, because the bottom number is 6, and that never changes. They all have 6 electrons, because we can see that they're not ions, there's no charges there. However, carbon 12 has 6 neutrons. 12 take away 6. Carbon 13 has 7 neutrons, because it's 13 take away 6. And carbon 14 has 8 neutrons, because it's 14 take away 6. So like I said, if you are aiming for those A's, A stars, maybe even a B, you want to be familiar with isotopes. This is a really nice question, I think. Once you understand it, you can apply it to any of them because they will give you the isotopes in the question. So it's not like you need to memorize, oh, carbon's got 3. You don't need to know that carbon's got 3 different isotopes. That's not in the spec. You just need to be able to use the information they give you to tell you the differences and the similarities in these isotopes. Okay? I'm trying to stop saying okay and so, but I'm working on it anyway. Well, that's everything for today, and I'll be back soon tomorrow. I'll be back tomorrow with another video. Thank you for watching.